Hello and welcome to this session of the Microsoft Build Conference. My name is Rainer Stropek, and I would like to say a warm welcome to everybody for half an hour with a topic that is very near to my heart. It's about coding with kids, how to cultivate the next generation of developers through playful discovery of technology. As I said, my name is Rainer Stropek and I'm broadcasting to you from beautiful Austria. I'm an MVP for Azure and Developer Technology and RD, and I have the honor today to talk about one of my favorite hobbies, that is coding with kids. So let me get right into the topic. And before I tell you a little bit about our experience with coding with kids and what works and what doesn't work, I would like to give you a brief introduction about my background so you know where my experience comes from. I had the honor to be a co-founder and currently acting chairman of the coding club Linz. Linz is a town here in Austria, and we started Austria's most active and largest CoderDojo. You might not know what a CoderDojo is, but you can guess it from this picture. CoderDojos are worldwide active, volunteer-led programming clubs for kids. Kids between the ages of 8 and 17 come to us, and volunteer mentors work with them, teach them their first steps towards coding. Some of them, young coders, already have some experience with coding, and we help them to discover new things in terms of software development. Let me give you a brief overview about what CoderDojo is. The CoderDojo Foundation is a non-profit foundation acting worldwide, and here you see a screenshot of all the CoderDojos that exist worldwide. As I said, it's a volunteer-led programming club, and you might also know the CoderDojo Foundation from something else. The CoderDojo Foundation is a cooperation together with the Raspberry Pi Foundation. So the Raspberry Pi and the CoderDojo, they come essentially from the same home. Everything started in Ireland, and nowadays there are more than 1,000 CoderDojos distributed all across the globe. If you take a look, just use your favorite search engine, type in CoderDojo, and it's very likely that you will find a CoderDojo somewhere near you where you can also join such a programming club. Now, for us in Austria, the journey started approximately 6 years ago. This is in fact a photo of our very first CoderDojo. We learned about CoderDojo at a conference, an IT conference in the Netherlands, and we were immediately fascinated. That is my wife, Karin, she's also a programmer, and we thought, hey, something like this should exist in Austria. And therefore, we founded our local CoderDojo, and we immediately started with a bunch of kids. We didn't really know what to do. We had to learn it on our way. And now it is 6 year time, and we do every Friday, weekly meetings together with kids, doing a lot of coding, soldering, and things like that. Let me show you a bunch of photos. You've seen a picture of one of the first CoderDojos, and this is now a CoderDojo pretty much right in front of the COVID crisis. This is how a typical CoderDojo in our city looked like. The physical CoderDojos happened happened bi-weekly, and this is one of the first tips that I would like to give to everybody who wants to start a programming club similar to something like this. If you want to work with kids, one of the most crucial things that you have to do, at least it was one of the most crucial things for us, is that we do it on a regular schedule. If you do it only every now and then, kids and also parents don't really know how to plan. They aren't really they aren't really planning to visit your CoderDojo regularly. By having a clear schedule, for instance, bi-weekly or monthly or weekly, that is the most important thing that brings kids to you and that keep kids coming over and over again. Now, of course, COVID crisis changed a lot of things for us, but we didn't stop. We didn't stop our CoderDojo. On the contrary, we switched to online meetings with our kids, and it worked pretty well. What we did, we switched from bi-weekly to weekly, and we changed our approach a little bit. In the physical CoderDojos, it worked very well to invite kids, to give them some exercises, written exercises. I will tell you a little bit more about that in a few minutes. And in online CoderDojos, we switched that a little bit more. For online CoderDojos, it is more like an instructor-led workshop. So the mentors, here you see a photo from my wife Karin and me sitting in front of the computer doing a CoderDojo. In such online CoderDojos, we more focus on certain topics and then have instructor-led workshops, but also for kids who have never done any programming before, and also for young coders who have already a little bit of experience and who just need a little bit of mentoring to get deeper into software development. So we didn't let us stop from COVID, and luckily, situation is getting easier, especially here in Austria and in Europe. So here you see another CoderDojo that we did last summer, where we started first CoderDojos which were in present, where we met physically with the young coders again. Now, you have a little bit of a background what I do and why I am talking here at the Build conference about coding with kids. Now, the most important part of this presentation will be sharing our approach. What we learned works pretty well, and what we learned what doesn't really work. So let's dive right into this topic. The core idea of every CoderDojo is not to be a school. It is not a computer school. We as mentors do not teach software development. We do not teach the theoretical underpinning of software development. We do not teach the theoretical concepts of programming languages. On the contrary, what we want to do is we want to make sure that kids who love playing use this fascination for games to discover coding and discover software development. The most important topic in CoderDojos is to let kids playfully discover technology, playfully discover what they can do with software development tools, for instance. Now, of course, the tools must be different depending on the age and the existing knowledge and experience of kids. Let me tell you a little bit more about what we use in this area. Before I do that, this picture should symbolize the problem that many schools have when they try to teach coding to young persons, young people, and to kids who haven't done software before. Many schools, or in traditional schools, software is taught like mathematics or physics, where the focus in the first steps is on the theory. It's on the theoretical underpinning, and it makes absolute sense. If you work with older kids, with adults, for instance, it makes sense to teach computer science and programming from the very ground up. First, learn the basics, and then build on these basics to discover more advanced scenarios. But the problem with kids is that they don't like to approach a topic like this, at least in our experience. They want to dive right in. They want to experience the technology immediately. They want to type something, and within a short amount of time, they want to see results. They want to understand why it is important to really learn about programming languages. They need context. They need to understand why they should spend some time with it. And this is exactly where we use games. For instance, here you see a screenshot of a game that we do with very young coders, with kids who maybe have visited us for 2 or 3 times. In this case, this game is about firing this bananas to this ape in order to let it enjoy these fruits, these bananas. This is a funny game, and building it using a platform called Scratch, I will tell you more about that in a few minutes, takes a little bit of time because it also touches topics like mathematics and physics, because here you have to calculate the path through which the banana is flying through the air to really reach the ape. Now, what we typically do, we do not start by teaching underpinnings and theoretical concepts of programming. We do not talk about mathematics and physics because even the physical principles of programming something like this would be way too hard for children. But we simply want to have fun. This is the experience that we would like to have. So what we do in order to work with children in that area is we give them, similar to Lego, for instance, a very simple instruction kit. Let's call it a hands-on lab that they can just use to rebuild exactly that game. They do not need to understand in the first step how all these things really work in detail. On the right hand side, you see such a hands-on lab. It is in German. Don't worry, if you don't understand German, it is absolutely no problem. The important thing is the general concept. You see, this is called a block programming language, and here you see a screenshot from Scratch. Scratch is exactly such a block programming language. Scratch was developed by the MIT, but there are more block programming languages than just Scratch. We happen to use Scratch for the very young kids in particular. And the idea here is to not describe and understand every single step, but the idea is to just hand out the step-by-step description of the game and let young kids simply rebuild the app by just dragging and dropping all the different items into the right direction. In many cases, the very young kids don't really understand all the nifty details that are hidden in these Scratch exercises, and that's absolutely no problem. It's just like with Lego. You take the pieces. If you haven't done any Lego before, you just follow the step-by-step description, and at one point in time, you simply see what's going on, you see what you are building, and at the end, you have the pleasure to have something that you have built, but you had a clear step-by-step description. Now, when kids get more experienced, they maybe they maybe start to build more complex games. Here you see some examples of games that we build with very young kids using the Scratch technology. You see some very simple jump and run games, like with the Pico and the stars. You see some games where a shark is trying to fetch a smaller fish. You see a minesweeper version, you see some space shooters, you even see a simple Pac-Man implementation here on the right lower corner. These games have different levels of complexities, and many kids who don't really fully grasp the complexity of programming languages still manage to build games like that by simply following the hands-on labs, and they have a lot of fun with it. Sometimes also they build these games together with parents, for instance, and sometimes they build these games together with mentors, or they sit together, 2 or 3 kids, and they build a game like that together. The important thing is the step-by-step description. Over time, the kids playfully learn to understand what a sequence of command is, what an if statement is, where and when to use a loop, what to achieve by using variables, for instance. They get an intuitive understanding about how programming languages work. And they start to revisit the games that at first they just rebuilt based on the hands-on lab description. They revisit these descriptions and maybe do some changes. They add some additional figures, some additional sprites. They add some additional levels. They change the look and feel. They change the coloring. They add some end bosses. They exchange the whole topic of the game, replacing the, I don't know, the spaceship with a beautiful unicorn, and they don't let a spaceship fly through space, but the unicorn can fly through space in front of a beautiful castle, for instance. It's absolutely no problem. They can be creative, they can do whatever they want, and this is the kind of playful approach that we would like to offer to kids, and that, at least in our experience, works pretty well when trying to spark a kind of fascination for computer science in very young kids. Now, the magic that makes all that happen, at least in our CoderDojo, is Scratch. If you haven't taken a look at Scratch, try it. It's so much fun. The children love it, and even I, as a mentor, as a professional developer, enjoy it very much to take Scratch and build simple games with Scratch. As I told you, Scratch is a block programming language. That means that kids do not need to learn how to type. Typing is one of the biggest hurdles for young kids in order to learn coding. As professional developers, we sometimes forget how hard it has been when we started using a computer to find all the special characters. Where is the curly brace on my keyboard? Where are all these strange special characters, like the pipe character that you need for an or condition in expression in any programming language, for instance? With Scratch, you don't have to do that. Let me go quickly back in the slides and point your attention again to the right-hand side of these slides. Notice the colors in these block programming elements here. These colors help kids to find the right block for the right task. So if you hand them hands-on labs, and we have dozens and dozens of these hands-on labs of these small little games on our website, if they take this description, it's pretty easy for them to find the right blocks and to put these blocks together, to find the right places where to put a variable, for instance, how an if loop works. And if you take a close look, you will find on the right-hand side, even if you don't speak German, what might be an if statement or a loop, because it's this collection of things which are surrounded by another block, and this somehow resembles what they later will do in text-based programming languages like TypeScript or Python or C# and so on. So they get an intuitive understanding for some programming concepts. And this is turning the traditional approach of many schools upside down. Instead of first learning a sound underpinning of the theoretical concepts, we immediately dive in, we simply build something, we have fun with it, we try and experiment what we can do with it without fully understanding what's going on, and then over time, with gathering more experience, we try to change things a little bit, and at one point kids have enough understanding so they can come to us as mentors with their own ideas for games and build their first very own applications in Scratch, for instance. Well, point in time, maybe kids get bored about Scratch. Scratch is great, but once they have built 5, 6, 7 games, something like this, they want to do something else. So what we did at CoderDojo Links, for instance, we took the same approach and translated it, or tried to translate it, to tinkering and soldering and electronic basics. What you see here are soldering kits that our mentors created for very young kids who have never done any tinkering or soldering before. It is a super, super simple set. All you need is a piece of wood, a nail, a hammer, and a soldering kit. Excuse me. You take these paper bits, it's a little bit thicker paper, you take the nail, you create some holes, so it is you can touch something, you can use the hammer, it's a lot of fun doing that, and then you take the different electronic pieces, put them through the hole, and at the end of the day you use the soldering kit to do some very, very basic and simple soldering exercises, and hopefully after half an hour a LED starts blinking. And that is exactly the approach that we want to have. Again, we turn the traditional approach upside down. Kids do not have to learn first about electricity, about how LEDs work, about how a battery works. That's not necessary. All we want to have is a very simple approach, something that can be done for half an hour, maybe 1 hour, and at the end, we have a positive experience with technology. Again, over time, things become more interesting. And this will bring me to my next area in this presentation. Kids who learned to really work with Scratch, who learned to build simple soldering exercises, they are over time looking for challenges. If we stay in this topic or in this picture of Lego, they go from simple from simple Lego sets to more complicated technical Lego sets, like you see on the left hand side. We don't really do Lego in our CoderDojo. This is just an example, a picture that should make you understand what we are doing. On the right hand side, in fact, you see a real exercise that we do with kids when they start to having more experience with simple coding exercises. This is a fractal tree, which is rather simple mathematics and only a few dozen lines of TypeScript code. So what we typically do in the next step, we take the kids and move them with the same principle from a block programming language to a textual programming language, and in particular, we use TypeScript for that. TypeScript has been chosen by us, especially also because of the IDE, the integrated development environment, StackBlitz. We love StackBlitz. StackBlitz is essentially Visual Studio Code, but just in the browser. Why do we love StackBlitz as the next level in our CoderDojos? Because kids don't need anything to get started. With StackBlitz, we can also create very simple exercises. Let's say a basic skeleton of a TypeScript solution with just a few lines of code to get started. And we only have to hand out some URLs. Kids click on it or click on it on their own computer or through a Teams meeting when we do an online CoderDojo, and StackBlitz opens up. They are at exactly the right position in the source code and they can start working on it immediately. No need to install anything. It works on any device. All you need is just the browser, and we love that. And then again, we do not teach the theoretical underpinnings of TypeScript or web development first. The first thing that we do when kids transition from Scratch to textual programming is we just give them exercises where their job is just to type in the pre-baked code. They have to look for every single keyboard stroke. They have to find the special characters. And we try to celebrate every single line that we manage to type in correctly. We hunt bugs together. We share the screen. We try to make it a kind of quiz, a funny quiz, to find the missing brackets, to find the missing semicolon, to maybe together find out where a typo is. You really have to be very slow and consciously celebrate learning how to type. And only when you do that and when you offer positive experiences by building such games and by reaching positive intermediate results, you can motivate kids to come again and to be more interested in computer science, and to maybe then as the next step be be willing to learn more about the theory behind computer science. Now, we don't do that just with software. We do the same with tinkering and electronics. Here you see some more advanced projects where we use platforms like Arduino, or maybe do some advanced soldering, or we use the microbit, as you can see on the right lower corner, where again we combine the microbit block programming with a little bit of soldering and a little bit of just putting together an interesting interactive puzzle, like you see it on the right hand side. This is something what we really like to do because it brings together the idea of tinkering and block programming and maybe textual programming to build real world solutions. We want to encourage kids to get started with such projects, and over time, again, they develop a natural understanding about what's going on, even in these more complex scenarios and more complex project types. There are some success factors that we have learned in CoderDojo that let us fascinate kids for computer science and maybe even consider computer science as a possible option for their education and maybe for their later jobs. First, mentors material, and motivation. That's the 3 M's. And let me talk a little bit about that. Here you see, for instance, mentors. We cannot reach lots of kids without a large group of volunteers. So if you want to build a computer science club, a computer club, you have to motivate a bunch of people, and you have to place an equal amount of time to building a group of volunteers and not just focusing on the kids. You need the volunteers, and there need to be a real club spirit, a spirit in such a programming club, not just in the kids part, but also in the volunteering part, because you need a lot of helping hands when you try to also maintain the material necessary to run such a programming club. Here you see all our material, our laptops, our tinkering kits that we have on the road with us, and here you see our car. And believe me, you also need a lot of motivation doing that. It is motivating to work with kids, but at the end of the day, you need this motivation because it is a lot of work, and therefore it takes a real team spirit, and you have to work on this team spirit to keep all the mentors working together, trying to build a sustainable computer club, which does not just do one or two meetings, but which really lasts for months, better years. Now, the last thing that I would like to give you is this success factor. Be patient. As professional programmers, we often expect too much from kids. Small steps matter. In a textual programming club, in a textual programming lesson online, sometimes we only write 5 lines of code. Just being able to draw a simple circle or a smiley on the screen, and that's perfectly fine. The goal when you start to work with small children in computer science is not to immediately make them really well understood computer science experts. It's more opening perspective. It's the positive experience that we have to give young kids so that later on they consider computer science, as I said, as a possible option for their education and for their job. Now, I would like to close with a call to action. If you think that such an approach might be fun, also fun for you, then just start your favorite search engine and look for coding clubs around your area. I'm absolutely sure there will be a CoderDojo or any other programming club that needs your help. If you are a professional programmer, I'm pretty sure that you can help in such a coding club. And if it happens that you live in an area where there is no computer club, just start one. Do a CoderDojo or any other foundation that is offering free coding clubs to kids. It is a lot of fun. It is super, super motivating. And believe me, even if you are a professional programmer, you can learn a lot of soft skills by teaching kids how to code, especially if you also work as a trainer, which I'm sure that many of you do. Thank you for letting me share these thoughts. Let me leave this screen here for sharing the thoughts about coding with kids with you. I hope it was an interesting half an hour, and I will now take a look at my second screen if there are some questions which I might be able to answer in the last 2 minutes that we have. Okay, the first one is, what age is appropriate for kids to start learning? We in our programming club, we expect kids to be able to read and write text. So we start 7, 8, age of 7, 8, something in this ballpark. There are other platforms where you also can find very simple drag and drop games for kids who cannot read already, but this is not an area where I have expertise. We start with kids who can already read a little bit. This is necessary for Scratch. The next one is a lot of coming in. Let me see. What is the best advice for building a clubhouse environment? We are lucky. We get free rooms from the city of Linz. So the city of Linz offers us rooms where we can meet with kids, and that works perfectly fine for us. In this case, we are lucky. Um, Yeah, I see you. Somebody said the same. Reading is a minimum. What is the best tip for keeping kids motivated? Do not expect too much. I said already, small step matters, and try to give them quick positive experiences. That would be my most important tips for you. Okay, let me see. Do we have anything else? Any online Coder Dojos? Yes, we are an online Coder Dojo, but we are a German one. So every kid, if you know kids, if you have kids, if you'd like to join us, join us. Just go to Coder Dojo links. But we do online Coder Dojos, as I said, in German. Do you have kids try to draw flowcharts by hand? No, unfortunately, I don't have experience in that area. Another one, Johnson is asking whether we have tried makecode.com. Definitely, yes, we have tried make code. Only recently it works nice, but because of historical reasons, because Scratch is longer, we have more experience in that area. We have more games in Scratch, and therefore we mainly use Scratch. This does not mean that make code is better or worse. Absolutely not. That's just for our Coder Dojo. We have more experience in that area. Okay, I think I didn't miss any additional questions. If I did, feel free to get in touch with me. You can find me on Twitter. You can find me on LinkedIn. Just connect with me, send me a direct message. My DMs are always open, especially when your questions are about programming with kids. I would like to thank Microsoft for giving me the opportunity to do this session. And with that, I would like to give back to the organizers and say thank you and wish you a very nice morning, evening, afternoon, wherever you are. Thank you very much.